We're now going to look more at writing equations of lines. Most of you are familiar with the slope-intercept form over here, where m is your slope and b is your y-intercept. We're going to use a lot in this course the point-slope formula. We're going to use it a lot in here. If you choose to take pre-calc and calc, it'll almost exclusively be used, with only using the one you're familiar with a few times. So we're going to try to get used to using this one here. It's called your point-slope formula. M is still your slope, but the x1 and the y1 is a point that you are given. When you're trying to find an equation of a line, you're always going to have an x and a y left in your answer, with the exception of a vertical or horizontal line. So here we're asked to find the equation of a line that goes through this point and has this slope. Since you're given a slope and a point, we're going to use the formula that has a point and a slope in its name. So that's your point-slope formula. Remember, m is your slope, so we're going to replace m with your slope. X sub 1 is the x-coordinate of the point you're given, which is your 5. Y sub 1 is the y-coordinate of the point you're given, which is negative 2. Now, all we're going to do is go ahead and get rid of your parentheses by distributing through your fraction, and we get this. Now we're going to get y on one side by itself, so subtract the 2 from each side, and then we have our equation of our line. Here you're asked to figure out the equation of a line that goes between these 2 points. Well, no matter which formula you want to use, the point slope or the slope intercept, you need to first of all find your slope. So remember, rise over run, changing your y's over changing your x's. So we end up getting a 10 over a negative 5, or a slope of a negative 2. Now, since we have a slope right here, and we have a point, we actually have 2 points, I'm going to use my point-slope formula. Now, which point you choose does not really make a difference. I am going to use this first one here. Notice your x sub 1 is your x-coordinate of 2. Your y sub 1 is your y-coordinate of negative 3. Your slope right here for m is what we figured out over here of negative 2. Distribute through. Then get y by itself by subtracting 3, and you're done. So, looking at this one here, we want it to be perpendicular to this one, going through this point. Well, if it's perpendicular, you got to first of all figure out the slope of this line. So, to figure out the slope of your line, you got to go ahead and get y by itself. So let's take a look at that over here. Let's go ahead and try to get y by itself. So we'll subtract a 3x from both sides, and we get this. Now we got to get rid of the 2. So divide everything by 2, and we get this. Your slope then is always the number in front of x when y is on one side by itself. So our slope is negative 3 over 2. But since we are looking for perpendicular, you got to take that fraction, flip it upside down, and change the sign in front. In other words, our slope that we need to use, since it's perpendicular, is our 2/3. Our point is 4, 5. So we might as well use our point slope formula again. Plug in your y value for your y1, equaling your slope, which is 2/3, times x minus your x-coordinate of your point, which is 4. Distribute through, and then go ahead and get y by itself by adding 5. Here it needs to be parallel to our line and needs to go through this point here. Parallel means it needs to have the same slope. Well, y in this case is already on one side by itself, so your slope is what's in front of x. Since it's parallel, we know it's going to be the same, so what we're looking for is a slope of 3 going through this point. Once again, we have a point in the slope, so we'll use our point-slope formula, y minus our y-coordinate, equaling our slope times x minus our x-coordinate. Distribute through, add 5 to get y by itself, and that's it.